Hi students, this is 5.2, a continued lesson. So here in this lesson we're going to talk about function notation. Okay, so when we talk about function notation we speak specifically on how to write an equation using this notation. So for example, what you've been normally seeing is if c equals to 15 plus 2n, this notation shows that c is the dependent variable and it depends on n is the independent variable. Okay, so the function notation looks like this. C, n, in brackets, equals to 15 plus 2n. So notice that all I've really done is just added this brackets of n here. Okay, so n here is the same variable. And the way you would say it is here is a formula equation called c of n or c at n. And basically what you're doing is when n is a specific value, okay, so let's say n equals to 3, so let's do that. So if n is equal to 3, you would write it like this. 15 plus 2 times 3, which is c of 3 equals to 21. Okay, so what you're describing here is when the value of n, for example here is 3, the value of c at n equals 3 would be 21. Okay, so this is just a way to describe the value of c while still using the value of n. Alright, so example 1. Carmen works for a research company in a shopping mall. The equation p equals to 5n plus 30 represents her daily pay, p in dollars, when she conducts n surveys. Okay, so for every survey, she's getting paid, and she gets paid a certain specific amount of money. Alright, to describe the function, write an equation using the function notation. Okay, so the first thing we're going to do, we're going to describe what this 5n represents. Well, think about it. If you conduct one survey, you're going to have 5 times 1. If you conduct 2 surveys, you're going to have 5 times 2. So really what you're saying is you're getting paid $5 per survey. Okay, so describe the function. So Carmen gets $5 per survey. Okay, and this 30 and notice this 30 is a constant. So this 30, the constant, represents probably her pay that she automatically gets every day. So she gets $5 per survey and $30 for the day of work, we're going to call it. Okay, so what happens is, if I was to write it in function notation, I would just say, okay, her pay at a certain value of surveys, certain number of surveys, equals to 5n plus 30. Okay, so again, all I've added is p of n equals to 5n plus 30. Alright, so find the value of p8. What does this number represent? Well, let's first talk about what the number represents. The number represents 8 surveys. So we're basically saying 8 here is n. So here n is equal to 8, which is 8 surveys completed. Okay, so now to find the value of p of 8, so we're first going to understand what p of 8 means. So p of 8 would be her total pay after 8 surveys. Okay, so n equals 8, that represents the 8 surveys completed. P of 8 represents the total pay after 8 surveys. So what we're going to do is we're going to plug in 8 into our formula. So P of 8 is equal to 5 times 8 plus 30. So P of 8 equals to 40 plus 30, which is 70. So her pay after 8 surveys is $70. So notice this function notation still keeps in context what you're actually finding. So instead of saying P equals 70, so you don't really know what your initial value of n was, now you can say P of 8 equals 70, which means that you know that 8 surveys will produce $70. Alright, example 2. Write in function notation. So notice here in this formula we have P equals to 2s plus 15. So s is your independent variable, P is your dependent. So what we're going to write is that P of s is equal to 2s plus 15. Okay, so similar here, we have y equals to negative 3x plus 5. What we're going to write here is y of x equals to negative 3x plus 5. Okay? All right, so write as an equation in two variables. So here, dt equals to 4t minus d minus 7. So maybe this is a distance time formula, most likely. So we could say this is the distance is equal to 4t minus 3. Minus 7. Okay, g of x. Okay, so that's often a representation for y. Okay, so again, this is kind of like your y variable, right? And then this is your x variable here. And when you're sketching a graph, so this is your independent variable. So here you could have g equals to negative 2x minus 3. A lot of the times, another way we'd write this, because g represents your y variable, we would often write y equals to negative 2x minus 3. Okay, so now last example. So we're given a function notation f of x equals to x squared minus 6, sorry. So the function f according to x is equal to x squared minus 6. So find f of 0. Okay, so that means I'm plugging in x equals 0. So notice I'm replacing x with 0. So what we have here is f of 0 is equal to 0 squared minus 6. And I like usually put in brackets around my 0, so maybe I'll rewrite that a little bit better. 0, that. Okay, because I'm replacing x with 0. So 0 squared is obviously 0. So f of 0 equals to negative 6. Alright, so this question is asking a little bit differently. We're giving you the value of f of x is 30. So I'm saying that f of x is 30. I'd like to find x. So what I'm going to do is I'm going to replace f of x here with the value of 30. So what we're going to get is we're going to have 30 equals to x squared minus 6. And we're going to bring this 6 over here. So we have 36 equals to x squared. And now we have to take the square root to solve for y, or solve for x. And we'll have to take the square root, which is now plus or minus 6 equals to x. So what you have to be careful of, whenever you take the square root of something, technically you have two different values that come up. Because if I was to plug in negative 6 squared or 6 squared, both of them would give you 36. And if you go back to the original question, both of those would be correct. So notice, if you plug in plus 6 squared is 36, 36 minus 6 is 30. If you were to plug in negative 6 squared is 36, minus 6 is 30. So both of these values would be correct. Alright, good luck with the lesson, guys, and hope everything made sense.